Hey there guys, and welcome to another design stream. So, what do I got right here in front of us? This right here is the insides of a power strip. And what the plan is to desolder these copper, brass, whatever you want to call them, strips, replace it with wiring, and then connect panel mount sockets to it and have that in my desk. This has been, like I said in the description, a long time coming. I originally bought these panel mount things for this project like a year ago. It's just one of these things. I frankly have several power strips around my desk to begin with, so I never actually needed it. That changes a little bit when I've got this, for example, controller and other things I want to plug in that are various voltages. Now it makes sense to have a power strip, a dedicated power strip for projects and whatnot on the desk. So the plan is not just to have these panel mounts, but also to have outputs for various voltages built into the panel, and then I can plug stuff in as I need them. Also, while we're at it, lights are installed, as you may be able to tell, and right now they're at an acceptable brightness for the fact that they're not going directly into my eye. I had them tilted up a little bit more earlier, and they were directly in my eyes, and that was way too much, and I would have needed to turn them down, but I tilted them down so they're facing straight down at the desk, more or less. And frankly, it's not bad. It's not bothering my eyes too much. Right now, I am running them off of my bench power supply, so that is a temporary setup. And once we get this all set up, as part of putting that all together, I will get these hardwired in. How exactly I'm doing that, I'm not entirely sure. Let's talk about some of the wiring stuff. Well, first off, because I have this here, like I said, this was about a year ago that I bought these guys, and I just left them in the bag and never looked at them. And as you can see on the screen there, that is not, at least for my part of the world, a standard plug. So it seems I made a bit of mistake. I'm not exactly sure how I made a bit of mistake, but I will have to buy new panel mounts. We're going to just live with that for the time being. I'm going to assume that this is standard size, and then if I need to change things, I will just do that in the future off stream, because it's a minor change and shouldn't really be a problem. So that's that out of the way. I am going to have to actually get correct plug panel mounts for those. And then for the other voltages, there's a couple things, right? So I do have buck boost converters. I do have, well, I wouldn't really need the boost converter part. I would only need the buck converter part. I do have several linear voltage regulators in various sizes that I could use. And then this is another idea right over here. And that is various chargers. So given that these take AC input in and output a given voltage at a certain number of amps, the other possibility is for achieving the different voltages that I need to, cut the end, as I've done on this one, and use those ends as output. I have done that before, obviously. That's why this guy's cut up for projects. This guy in particular, this is a laptop, power supply. It's 18 volts, if I recall correctly. 18.5. 18.5, 3.5 amps. So the 3.5 amps part is plenty good. The 18.5 obviously is overkill for most everything I need. The highest thing that I need at the moment is 12 volts. So this would then have to be stepped down with something else, so probably not using that. Furthermore, what I was actually going with this is, when I used this in the other project, it actually was capping the voltage. It was, sorry, just give me a second, because it sounds like my music got a little bit louder, and I've been messing with the music trying to get it just right for streams, and frankly, it is difficult. So anyway, basically, if I recall correctly, the last time I used this, I hooked it up to an electromagnet, and the overcurrent kept on tripping it internally, so it was stuttering, which is a little bit weird. And by a little bit weird, I mean, I guess it's good, but I would prefer that it just clamps the current instead of tripping. But one of those things, I'm not really an electrician, so I rest assured that there are probably benefits to tripping it instead of, and when I say tripping it, it was tripping and resetting itself like multiple times a second. So you'd hear the electromagnet on, off, on, off, on, off, almost like a wave sign, basically, kind of thing. And that was really weird. I mean, I don't know why you'd reset yourself if you're going to trip yourself. But again, I'm not the professional here. This one's a standard 5 volt 2 amp guy right here. So this would be another example of something that's actually completely useful. I could, in theory, plug this in and then run this wire up to the panel mount. And there's my 5 volt output for any projects that I need. And this guy is actually one of the it's one of the power adapters for the lights that we have here. And this one's a bit of an interesting thing because these lights, if I have them both at max output, they will go to 3 amps. This is rated up to 2 amps, so that is not quite enough. But 2 amps is actually where they're at right now, and they're pulling a little under. Yeah, they're pulling 6.3 according to my bench. And my bench power supply says they're pulling 6.37 when they're capped at 2 amps for the brightness that they're at right now. So it's one of those things, I'm tempted to hook this up to these two at the same time and see what happens. See whether or not this doesn't catch on fire, or whether or not I can actually just run it and it will not be at maximum brightness, which is not what I need. I absolutely do not need these things ever at maximum brightness. So this is a possibility for the lights. It's the exact voltage that they're looking for, in theory. And the amperage, again, I don't need the full 3 amps. This 2 amps is plenty. So we'll consider that. So that is all the prep work for talking about how this is going, how this is being set up. Let's look at what I had made up whenever it was I was working on this last, at any rate. I don't know if that was specifically last year or if it was a bit longer. You know, not sure what the exact range is there. So, actually, this says 2019, so it has been a good bit longer than I thought it has been. Okay. Again, obviously, as I said, not really necessary, which is why I never did it, because I've got plugs all over the place over here, plus my lab bench power supply for any projects that need a specific voltage. So, being as it was not necessary, it is not something that got done up until this point. So this is what I had before, and you can see that this, basically the cap in there, the panel mount, just slips right through there. This is a hollow block. The wiring could go in there, no problem. One of those things, if I want to hot glue, insulate, whatever, I could do that. These little tabs on the side were my attempt, and it's one of those things. Attempt is not even necessarily the right word. It technically works, but it's a push latch. So you push it in, it gets caught. You push it a little bit further, the tab catches or gets pushed to the side and then falls back down straight on top of this ramp, and then slides off to release it. And this whole entire thing pops out. That's the idea I was going for. You can also see over here, I also had these other ideas where, because I wasn't doing springs yet at this point, I wanted to try to print my own kind of springs here. I'll go ahead and open them up. So you can see I tried these like wavy plastic spring type things, and they're printed in 2 parts because obviously this is a bear to print like this. So the waves were printed on their side. At least that's how I should have printed them. If I didn't print them that way, I don't know what I was doing. That way the strain, is along the layer line as opposed to perpendicular to the layer line, as we've talked about before. Makes it more resilient. And then over here, this one obviously would have printed like this, and that is in line with the layer thing, so one of those things. But the idea being is that these just kind of force it down and up. So that was just the idea there. Very interesting ideas way back in the day. Beyond that, this was at least the start of what I was looking at. I don't think the sizing here is really accurate. I think I was being a bit ambitious. And so basically, again, you've got these guys. Each of these guys are supposed to pop out. And the push-push mechanism can go left-right, so it's not that big of a deal with the spacing this way. But the thing I'm looking at right now, as I look at what I did, is the wires that allow you to pull these sockets out and stretch them if you need the extra reach. Which, to be fair, may be overkill. It may not be necessary because whatever you're plugging in probably has a cord on it to begin with, and long enough cord. And we're only working on my desk, so one of those things. My desk is a decent size. Let's see. All right, looking like I'm guessing 24 inches. Actually, it should be about 26, 27 inches. Actually, come to think of it, because my desk tray things that I'm working on are 25 long. So give it an extra inch or two for the back supports. So yeah, desk should be about 26 deep, maybe 27, and then width, I'm gonna say 4 or 5 foot. So anyway, point being is that there's no way that this is really necessary, having these guys pop out, because in theory I'm only plugging things in on my desk, and I can't see anything with a cord being less than 3 or 4 foot long, right? Like a 1 foot cord seems a little bit unnecessary. So this whole entire push latch idea that I had back in the day, a nice, interesting idea, but I don't know that it was really something that I should be bothering with. So that is what I had made up back in 2019, evidently. And with all that out of the way, we can start actually talking about what I want to get done. So let me hop back up here to desk and actually put it in my desk project with everything else. I'm not going to bother saving these guys, because again, the push latch thing is not really necessary. And then I'm only going to take the dimensions for these panel mount stuff right here and preserve that, because again, it's not going to push out. So at this point, I may as well start from scratch, with the exception of the dimensions that I'm using here. So that is that. That gets us started to the start line. Just a minute. Alright, sorry about that. It's one of these things, springtime, I'm guessing. I'm just getting a little flabby from all the pollen and whatnot. Again, was outside basically all day yesterday, so one of those things that could contribute to the issue. And we will go ahead and remake this panel mount socket here, and I'll just take the dimensions that I had previous. And let me just roll back to see what I actually need. So is this... Okay, that looks like the outside, so it looks like it's 27 square. So let's go ahead and do that. $27 and $27. And let's look at this now. So that extrudes up like that. So that should be the top. Makes sense. And that's 3.5 there. And then I round the corners, it looks like, and put the sockets in. I'm guessing. Yeah. Alright, so rounded corners, I'm guessing that's just an estimate of 1.5. And then 12.7 on center. And actually, I will put the sockets in first. And one of these things, I don't think it's really necessary at the moment to model out. Actually, I'm looking at this, and the panel mount only sits in on the left and right and top sides. In other words, you can't, the bottom side of the panel mount actually is mounted flush. It's not mounted with an overhang, interestingly enough. So we'll have to see how that changes when I pick up my next one, my next set to use in this project, because again, this is not doing me very much good, these ones that I have here, since I can't plug anything into it. So let us do this, toss this in here, get a center point, quinkydink that guy, all this very standard stuff, and this was 17.5, if I, 12.7, alright, 12.7 it is. And that was center of the slots, it looks like, and I do not have an X and Y. I mean, I do not have a Y, I only have an X coordinate on that, so that's something else that's going to need to be sorted out when I decide on the panel mounts I will be using. But again, today it's not really necessary to have those dimensions right now, because the rest of the pop out is what I'm interested in. And we will just call this 10. And well, is 10 a little bit big? I think 10's a little bit big. Let's see. Maybe more like 7. 7, and then I'm gonna randomly guess that this is 3 here. And we will just randomly guess that from the top. Again, this is completely random. 12.5. Yeah, I meant to do 12. Alright, 12 is definitely too much. 10. I'll take 10. And the rest of this can be equals that guy and that guy. And then we can just toss this guy in here, make him probably relative to that, another 10. And five, I guess 5 makes sense. So that should be good. Distance all, flip it, and then we'll just round these corners like before. Actually, this one's looking more like a chamfer, so I will chamfer it instead of filleting. 1.5, cool. Alright, there we go. So there's our panel mount proxy. And I will go ahead and make a new folder here. New folder. Power strip. Built in. Select. That was not what I wanted to do. Whoopsies. Rename this really quick. Yeah. And then move this up. There we go. Alright. And now that we have that, we can go ahead and do the other one. So, let's talk about, gonna really quick get myself set up for drawing. Just a moment. And that involves moving the camera. Hopefully without breaking everything. And once we have the camera moved, then I will go ahead and swap us over to use the camera. Oh yeah, that's right. I'm also going to need a weight for my lift pod because I took that into work to epoxy it. Because what I was using as a weight is the top off a microwave transformer. And it was delaminating. So one of those things, figured I just epoxy it together and make it a nice solid block so it doesn't fall apart. Let us preview to make sure that I am in frame here. Huh, interesting. The lighting looks a bit different from this angle, which is interesting. I guess because it's kind of, the one light is kind of backlighting. I wonder what happens if I turn the one light down. Nah, I guess I will leave that more or less like this. The other thing is, the other idea I have with these lights is it's a pain in the butt to reach up and toggle the brightness on them. I'm assuming the brightness is literally just a variable resistor in there, or just a pot, which suggests that I might be able to switch it over, just open it up and swap it out for an electronic variable resistor, like digital variable resistor, whatever the heck they're called. At which point I can set a microcontroller up on it, and then add infrared, right, and make myself a little controller, which would be fun. So then I could control the brightness via controller, is the idea. Anyway, let's talk about, because I didn't really talk about it in Fusion, how I'm looking for this to work. So I guess I'm going to try to draw this a little isometrically. That's the word I'm looking for. So we're going to have a hole in my desk here. Going to cut a hole in the desk, and baseline, the hole is going to be flat. You're just going to see plastic. And then I want to be able to push down, or otherwise pull a clamp, pull a little, what do you call it? A little latch. Either push down, push latch, or pull a little latch, which would allow this to spring up. Like, and how does that get drawn? Actually, ignore that line right there. I guess this would be drawn more like this. Alright, and we can ignore my lack of artistic ability here, but it would flip off a hinge on the back corner to be facing diagonally up like this. The chances are you've probably seen situations like this, setups like this with power strips. So basically it just hinges up. So pretend this is my this is my desk, and this is the plastic right here. So pull a latch, and then this hinges like this, and the mounts are in the front like this, facing straight towards you. That's what we're looking to do. Now, how exactly that works is up to debate. The most reasonable, I think the most logical rather, way to do it is to have a torsion spring on the axles, and then the torsion spring obviously winds the charges when it gets pushed down, and then it releases energy as it when it gets released by this latch right here, and allows it to lift up. The other alternative is to have a spring down here that actually pushes this up, and it's one of these deals where this front panel, even though I drew it a bit wonky, would in theory finish lifting at that edge right there, so you'd never actually see the spring. That is a bit easier to do because all you do is just drop a spring in there and you're done, as opposed to the ones on the axles. Now you got to make sure that this torsion spring on the axles is locked in and it's not going anywhere, which, you know, one of those things, not terribly difficult, but is an additional step and an additional point of failure. Unlike the torsion spring down here, which one of those things you can more or less just glue it in place and it will just go up and down, no big deal. And I mean, I say one here, but it could be one on each corner, it could be 3 across, whichever. So that's what we're looking at for the for the design. So first thing I want to do is, let's see, I just started a sketch, but probably should not. Probably the first thing I should do, one of these things where this being a base feature, this panel mount plug right here being a base feature, I'd prefer to insert it instead of deriving it, but we won't be able to update it if we only insert it, so I will go ahead and use the derived situation in this, or the derived feature in this situation rather, is what I mean to say. And again, I don't have any right now, but I will select it anyway. Oh, whoops. Gotta save first. Right. There we go. We will be able to drive features later on once I add, or not features, parameters later on once I add them. So that is why I have those selected right now. Built-in power strip, let's go. And there is that. So first thing I will do is actually let me see this guy, because this right here should be this distance here. Actually, I probably should not click that. I should probably click the face. That face to that face is my overhang in theory, and that looks to be 1.5. So we will go ahead and face width is 27 and face overhang is 1.5. Favorite them so we can get to them, and then I will hop back in here really quick and face, whoops, not that one. There we go. And then we can save this, and again, since we're using derive feature, may as well make use of the derive, all the functionality of the derive feature, so we will do so. And at this point, we can go ahead and start considering where we want to start building. And I think it makes most sense to build from the face of the, I'm going to say the face of the power strip itself. So we will do so. So first thing we need to do is we need to hop in here to parameters, because we, all the other plugs that I'm going to put in here are going to be smaller than these panel mounts, I'm pretty sure. And furthermore, I do not see any reason at the moment to, I don't see any reason at the moment to include USB ports in the design. I'm going to hope that the USB port panel mounts are a standard size, that this 27 millimeters is standard size for panel mounts, and therefore the USB panel mounts, if I need them, will be that same size. I could be wrong about that one. However, again, I don't think I'm going to ever need USB plugs on this thing. And even if I did for some reason need USB plugs, I have a couple USB power ports next to my desk that I use for plugging my headphones and whatnot. So it's one of those things. It may be unnecessary concern at the moment. So I'm going to go ahead and bring those in. This height is going to be face width plus face overhang. And we're going to need overhang on each side, so that will be ×2. And then, I'm going to go ahead and leave that like that. Actually, will I? Yeah, there's a couple different ways that I can do this, right? So we can start out with the face width, and this will be an open hole right here. Whoops. Face width. Let me just get the center really quick. And then we can go ahead and offset this by overhang. So that would be the overhang that the so this is the maximum outer spacing of the panel mounts, and then I can actually, I probably shouldn't do this one, and I'll tell you why. Because what I was going to do is do this and do that, and as you can see, that does not work. So instead, we will change this to that plus whatever I want for extra meat, which again, my wall thickness is normally like 3 millimeters, so I'll just go with my 3 millimeters. So that will go ahead and get us set up for success. I think I will go ahead and draw the first one in here. The first slot for the panel mount. So this will be face width minus. Actually, that's right. That's right. The face width includes the overhang. So good thing I'm talking through this right now and not just randomly going. So this should be minus overhang because this is just the times 2. This would just be the space that just the hole for the face mount to go into, and this is going to be the same size. It was what my point was going to be. And then this guy, yeah, that should be fine, honestly. Yeah, that should be fine. Cool. And then we can go ahead and extrude this. So I'm going to go ahead and extrude all of this. Let's go ahead actually, and before I do that, change parameters, wall thickness. This is going to come up a lot, so that's why I'm doing it. Do I want to go down 2 millimeters? So because I'm going to have a lot of stuff jammed in here, saving what space we can is probably correct. So I'm going to go ahead and change that 2 millimeters and call that wall thickness. There we go. And then I will go ahead and just extrude out a flat plate wall thickness. And once we have that, that did not work. That did not work because that tried to cut the object. Good. So let's turn that off and try again. Wall thickness, and yeah, I probably should make it a new component on top of which. And this will be the power strip. Now I can go ahead and extrude that. Let me enter in there and extrude that distance all. So that's 1, and then we want to go ahead and pattern that 4 times. It could be whatever number of I want it to be. Any number of sockets I want it to be. It looks like this pack that I had is 4. It's a weird number. 4 is a weird number, but evidently. So we will go ahead and do 4. And the distance is going to be the face width because that includes our overhang. But that should be spacing. So face width. That will include our overhang. So if I take a measurement between here and here, this should be 3 millimeters. We'll double check that in a second. I could also add a little bit of offset. Whoops, no, turn that back to the reference, please. Thank you. I could add like an extra 0.5 millimeter just as breathing room. And I guess I will. Just to give ourselves a little bit of breathing room between the panel mounts. Just in case something is not quite lined up. And we wanted to go to 4, like I said. Alright, and there we go. Now, as you saw earlier, I did not constrain all my lines because I wasn't sure how much space I wanted for additional whatchalls. So let's hop back there and resolve that for additional components. And actually, before we resolve that, let me just take this, since I was talking about it. So this should be 3.5 at this point. And it is exactly 3.5. So we know everything is hunky-dory. That's an overhang on each side plus 0.5 millimeter for breathing room, for leeway, for variance, whatever you want to call it. So we will hop back up into this sketch. And now we want to define our overall width here. Actually, I'm going to do... So this includes my wall thickness, which I don't want. So yeah, I will do width here. So for width here, we want face width plus 0.5. That's our our spacing between, and that will be times 3, right? Or no, it won't be times 3. It will be times 3 if I do this here. I'm just trying to think because technically right here, right, I've got the 24 millimeters instead of 27. So I need to get that 27. I mean, it's going to be minus 1 overhang, I think is what it ends up being, times 4. Let's do this. And then I believe I am a little bit over, but let's visualize it really quick. So yeah. So if I am correct about what I'm thinking, then this will be from here to there. I'm expecting it to be 3. Am I expecting? That's not 3 though. That's definitely not 3. So what is it? It's 7. So what does that say? Because I have the overhang on the left hand side. Oh, plus the wall thickness. That's what it is. So it's wall thickness times 2 is 6. Or no, is 4. 4 plus the 3 that I was looking for, right? I said 3? Yeah. So 4 plus 3 is 7. So that is actually correct. Okay, so I did need to subtract the one overhang on the left hand side. Cool. All right. I was right. I'm happy about that. Minus overhang. And that gets us exactly what we need for the panel mounts. And now we can go ahead and actually I'm going to copy that out. And I'm going to go ahead and make that a parameter just to make my life easier. So this is going to be panel mount space. And hit OK. And then I can change this to panel mount space. Size didn't change, that's good. And now I can add in extra space for the other attachments that I wanted. So that is a question though. What other attachments do I want? Obviously my XT60s. Do I have XT60s modeled up already? Let me check. And actually I think they would. This is another project I haven't shown you guys yet because it has been an utter failure so far. Obviously I've done several different versions of it, but this one day I would like to get finished. Just has not happened yet. Okay, it doesn't look like I have the actual object modeled up, but I do have that space cut out. So let me go ahead and hop in here and just get those sizes. Keystone panel. And, oh, no, I do. Cool, nice, sweet. There it is. I don't know what it's doing all the way back there, but good bunch of men. That is inside Keystone panel. XT60 mount. Did I design this in here? I did. Okay, let us copy, save copy, and you are going into miscellaneous. And you are just an XT60 panel mount. Sweet. Alright, cool. That saves me some effort. Close this guy up. Don't save. Miscellaneous. Whoops, that is not correct. XT60. Where you at? XT60 panel mount. There we go. And now we can finish this sketch. Excuse me. Where do I want to bring this in at? I guess may as well bring it in at the very beginning, just like I brought in the whatchamacallits. Proceed. Hit OK, just like I brought in the other thing. And let me hop in here. Do this. And let me see. This should work, right? XT60 hole spacing equals. And hit finish. And yeah, I will go ahead and come up here. Whoops, not that. What am I doing? XT60 width equals, and XT60 height equals. I actually probably don't need the hole spacing, but I grabbed it anyway. So there. The other thing is... Nah, never mind. Ignore what I was about to say. Alright, there we go. So, we can come back here, collapse that, and come back to this guy. And let's do... Well, let's see. The XT60 height is what again? XT60 height is 8 millimeters. So 2 of them do fit within the 24 millimeters, so I can stack them too high, which is nice. And we will do an array of 4, I think. And yeah, I think we'll do an array of 4. So let us go ahead and to that panel mount spacing, we'll add 2x, 2x, 2 times XT60 width. There we go. And we can add on top of that. Yeah, it's one of these things. If you look at it, the connection is actually contained within that. Let me double check myself on that one. I might be. Grab my XT60s. Bum 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 bum. And plug one of them in just to make sure I know how these are going together. Where's the female ones? Or I guess the male ones. Yeah, okay. I am not talking incorrectly. That is exactly how it works. The male ones do plug directly inside of those ones. So I do not have to worry about compensating for the outside or anything like that. So we just want to probably add, again, the 0.5 millimeter just to make sure that nothing's butting up against each other too badly. And I guess I will do that. It's only 2 of them, so I don't actually need to add more than once. So that should be good. Now we can come back in here to the power strip. And we'll take a construction, because I don't think we have one of those yet. Nope, we don't. And that's the face of power strip. Outside face of power strip. Click in that. And let's see. I'm going to project the... Actually, I take that back. I'm going to back up just a second. And before we do that projection, I'm going to go ahead and put the panel mounts in here. And the reason I'm doing this is so that I can project off of that. Not as built, align is what I'm looking for. That way I can project off of that for the edge. Otherwise, the alternative is, you know what? Yeah, I changed my mind again. I do that a lot. I change my mind a lot. So the reason why I'm not aligning it right now, aligning the panel mounts right now, is because the fact of the matter is that we have an issue in Fusion where alignment does not have a history to it. And because alignment does not have a history to it, when you make changes, the alignment does not update itself to take the actions that you asked for to begin with. So if any of this changes and these panel mounts, for example, shift a little bit to the left. So for example, I decide rather than 4 of these XT60s, I want an array of 6, so 2 by 3. So this gets wider, and now all these panel mounts that I just aligned are now out of place. They don't line up. But I then go and project off of them onto this sketch, and they are in the wrong place, and therefore all my other measurements that I'm taking off of them are in the wrong place. So it's better off to, instead of having go back and fix that in order to have the sketch update correctly, it is better to just go ahead and use the numbers that we have, which is why we have parameters in here. So this is overhang, and that's a minus. There we go. And I can just use this. This is never going to change. This is always going to be based on this face right here, or this hole technically right here. And I don't have to worry about it. So let us go ahead and mock up some XT60s, spacings. This will be wall thickness. Yeah, I guess I'll do wall thickness here. Makes sense. And I think that is absolutely what I should be doing. But this, there we go. Just waiting for Fusion to catch up. And actually, you know what? I will go ahead and I keep on calling it an array, so we will actually model this as an array, which is logical. So I will go ahead and take the center line here. And remember when I said I wasn't sure if I was going to need the hole mounting, whatchamacallits? Well, now we're going to use them. And let me just take a quick look at something really quick. Quick. How did I have these mounted in before? Hold on. Actually, that project, the whatchamacallits, my Ender 3 electronics case that I just showed you, I still have the pieces to it over here. I just wanted to see how. Okay, so the opening hole, actually, it's one of those things. I'm gonna need the space in the back, so it's fine that we used we saved that parameter as the opening space, but I will need additional parameters to finish this one off in order to make the holes for it, for the XT60 to sit through. So let's back up a little bit and go grab those. XT60 panel mount. And actually, it looks like this guy right here is the hole I need. So let me just make sure I'm looking at that correctly. Yeah, I'm looking at that correctly. So let me just show you this so that you know what we're talking about. And for the record, one second. Oh shoot. Alright, so YouTube, chat froze on YouTube, so I didn't see you guys talking in here. My bad. I just noticed that all of a sudden my analytics said that I had a chat rate, which only happens when people are talking. So, my bad for not responding earlier. I was only seeing views. Whoops. So for okay, so Gail, your first question is about parentheses and formulas. It really depends. There are certain things that absolutely need parentheses, otherwise the formula straight up breaks, and other things where it does not matter. So it comes down to a situation-to-situation basis. Okay, I guess that's the only real question I got. So back to grabbing this. Come back in here, and this will be XT60 opening width equals, and this is right here, XT60 opening height equals. So now we got those parameters to play with. Come back in here to the power strip and back down here to sketch, and this can be opening width, and this will be opening height. And then this right here to here, actually I should draw, so this is going to be my actual hole, and then I'm going to need that overall width and height right here. XT60 width and height. There we go. We'll center these guys up, and that is no longer there because I changed my mind. Center these guys up. And that will be like that. Let me just drag these guys over here. Hi, Zeke. And that is wall thickness. And then over here, which is what I was about to model up, this is going to be my 0.5 for my spacing there. Now, for these guys, these guys. Let me just... What are you... Okay, you are confined to that line. That's good. Now I need you guys to be on your own line. And you guys need to be centered on the opening. So let's get that happening. And that looks to be that line. Make that a construction line, and then that can be hole spacing. There we go. And I have one more non-construction line in here that should not be, so we are good. Distance all. Let me quick look at, yeah, Squid Sisters, yep. Correct. Squid Sisters was the name of the song. Distance all flip. So that's the XT60 connector right there. And we can go ahead and, like I said, array this one out. So I will use features as always, and my direction will be in that direction. And spacing, we want 2 and 2 for right now. And then is there a, actually I think I'm blanking on whether or not there's a flip button in here somewhere. I don't think there is, and I do not see a whatchamacallit. So let me, no, okay, it's not going to, yeah, all of them are facing the same direction, so this is just gonna have to be negative at this point. So height XT60, actually width XT60 width and 0.5 or plus 0.5, and then like I said, this is just gonna have to be negative to change direction. And then this is XT60 height, and we'll add the extra 0.5 in here as well. And I'll leave it on adjust for, actually no, I'll switch it over to optimize. There we go. So there's our XT60 whatchamacallits. Now the next question is, do I want to do anything here with names? One of these probably should be 12 volt, the other one probably should be 5 volt. The question though is, do I want to dedicate it right now, or do I just want to come up with some solution? Nah, I guess I'm just dedicating them right now, because I'm not going to come back in here and rewire these in between each and everything. So I will go ahead and make one 5 volt and the one other, can't talk, one 5 volt and the other one 12 volt. So let's go ahead and get that set up. Hop back onto the front of face, outside of face, project, and then just line this up here. Make everything construction lines. Turn off the bodies. Toss the text in. 12 volt. And I guess we'll make that like 8. Let's see how that looks here. This is one of the interesting things. They've been improving the grab points on these guys, but they still are somewhat finicky. And you can't always get them lined up correctly, but at least they're improving how well these text objects snap into place. 5 volt, 8 millimeters, center, yeah, alright, cool. And center there. And we can go ahead and -1. That cuts that. And now we got 12 volt and 5 volt. At this point, now that I have, again, this is probably going to be all I put in here for right now, unless I think of something else. But since this face is more or less, as far as I can figure it, lined up, I will now go ahead and get everything set up with these panel mounts and whatnot. Let's see. What is the best way to grab the center of this? I guess there is not a best way to grab the center of this. So let's just go center here to start out with. And then we can align here to there and then do the offset. I think that's right. Yeah, alright. And then just slide them over by the offset. Component minus offset, or overhang rather. Call it offset a couple times there. One of these deals, again, this is supposed to be a base unit, so it really shouldn't be a problem rather, whether or not I use this array pattern, whatever you want to call it. Capture position. As always, a lot of times you don't want to do this, and which is why you'll see me do boundary fill, or what I've done with in a couple of other ones is copy and paste new. So copy, paste new, and that breaks the link between them. Otherwise, what can happen is you'll start making modifications to one and it will end up reflecting in the others. So the example that I like to use for a situation in which that will occur, let's hop over to the camera really quick just so I can draw it. So let's say we're making up a keypad, which has happened to be before. I've made up keypads, and you want all the buttons looking exactly the same with the exception of the text on it. So you put the buttons in, you array them out to, let's say 2x3 here. So you array them out, and then you say, okay, this is going to have a 1 on it, this is going to have a 2 on it, this is going to have 3 on it. You put the 1 on there, and now all of a sudden there's a 1 on each and every single one of the buttons. So that is why you got to be careful with arrays in Fusion, because it will not break this link between them, which will end up with any changes happening to one affecting the others, which in some situations is what you want, but in many situations is not, and therefore I feel like there should be a better workaround than copy paste new or boundary fill. But that is just me opining at the moment. Otherwise, like I said, we are safe in this situation because all these will be identical to just pattern out, and not feature. I want component. And that, and then this will be spacing. We want 4 of them, and the distance. Let's start 0.0. That would help. And the distance will be face width plus 0.5. And we just need to flip that around. Oh, I guess that's not going to work, is it? There we go. That's another funny thing, how sometimes you got to do negative and the other times you got to do start. And we'll get you over here. I guess just do that for right now. And then this guy actually gets aligned like this. That like that. And just got to rotate that up. Interesting, that does not... Okay, so I drew that up kind of funny then, in that case, when I did this design. Let me look at this really quick. What are you? Alright, I guess we're going to have to change this, how this is set up. So let's come up here, change parameters. And this was 15.5. Alright, change parameter. Opening width is not 14.2 evidently, so let's unclick that. Sketch 1. I'm just taking a quick look in the background here to see if there's anything weird going on. Where's the 14.2? I'm gonna delete that. Yeah. Crap. Capture position. This is a little bit of a problem. Opening width. Let's see. In theory, this is 1330, 1331. D1331. There we go. And now the 15 is actually XT60 opening width. The opening height should be right. Let me hop back over here. And did I not? Oh, I guess I gotta go to end. Nope. Okay, I guess it just ignored my alignment even though I hit capture align. Okay. Okay then. Alright, toss that in here. Flip it. Alright, we'll align it the other way first. Align being finicky, like always. So that, whoops, not that. That is going to be like that. Flip it around, okay. And then we can try to... And there's the other thing that you just saw right there, which is also interesting. You'll see how all the panel mounts disappeared when I did that. Did this not... Oh, this probably did update and it just updated to the wrong thing. Yeah, it updated to D1330. So this should be XT60 opening width. I do not see opening width in there. What happened? Oh, come on, Fusion. Stop being a dingus. Alright, let's see. Opening width. Gotta start it. There we go. So that is now white, but it's also not the correct height, which means that where is this? This is actually going to want to be... Where is it? There it is. This is just going to end up being height. And now let's try again to modify align that. And hopefully this works this time. And the other thing that I'm running into here is, technically speaking, if you look at this line stops short of the overall width, which is why it's not quite square in there. So I'm just going to align this wall to that, and then we'll align the bottom to the top. Just do it this way, face to face. Alright, and there we go. And now it fits as it's supposed to fit. So that's good. Alright, and I want to apologize, guys. The YouTube really is freezing up on me here with the chat. I don't know what's causing that because I literally restarted my computer before going live. So, let's see. To confirm, power sockets are electrical sockets. Are you doing USB right now? Is that why they are smaller? So, no, I'm not doing USB in this mount. Because I already have USB hubs around here, so I don't really need it. So that is the first thing. These are XT60s. I'll hop back over to the camera really quick. They are these special connectors right here that can handle a bit more voltage and are a little bit more secure just because they lock in a lot tighter. So this is for powering projects and whatnot. 5 volt and 12 volt, one of those things. 5 volt really doesn't need an XT60, but since I'm doing one set, I may as well do all of them. And then the, let's see. As for Fusion, what Fusion is, Fusion creates models. It creates a bunch of stuff. So it is a CAD program, a computer-aided design program. It has CAM functionality, which would be manufacturing, computer-aided manufacturing. I have used this with a CNC machine before. I have not used it, even though they offer it with 3D printing. Because, if I recall correctly, the 3D printing stuff actually only comes with the paid subscription. I'm just double-checking here. Yeah, I'm pretty sure 3D printing stuff only comes with the paid subscription. And the fact of the matter is that it's easier for me to just save the model and then put it into a program specifically for converting the converting the model to a sliced 3D printing setup. And I'm going to reload YouTube again to make sure there's no other comments that I'm missing. I guess not. Alright. Cool, so that gets me caught up. I'm going to switch over to from top chat to live chat and see if that fixes my issue with the chat not displaying. And then we will get back over to here. So go ahead and capture position and back to this is an array right here. We already know this is an array. So I will just go ahead and do the same thing I did for the other one. And direction will be, I'll just grab this bottom again. And these are 2x2s. Whoops, that is the wrong arrow. 2x2 with plus 0.5, and then again it's a negative direction in this situation. That is 1, that is not negative. There we go. And then this is xt60 height plus 0.5. And okay, so second direction is not did not pick up the way I wanted it to, so there we go. And there we go. So now we have all of our models in line here. And at this point I will go ahead and just do a rigid group because none of this stuff should be moving. And again, as usual, actually, yeah, so I probably should have better organized this. I should have made sure that everything that I was doing was put into the correct not supposed to. So this is one reason why that wouldn't work. With the derived components, again, for some reason this used to work. I'd swear this used to work, but right now it is not working. I cannot move the derived components into the power strip component where they should be. The XT60s should be fine, but since I can't do all of them, I may as well just cry about it. So we'll go ahead and rigid group like I was saying, and I'm just going to go ahead and shift select everything because we don't have anything else going on right now. So that is all now connected, can be moved around wherever, and we can get on to building the rest of it. So at this point we want a back to this. Inside face of power strip, okie dokies, and this is going to just be a very simple offset for the wall. Again, we had the wall offset already compensated for, so wall thickness, and just flip that around. Now I probably, you see how the XT60s line up directly with the bottom? One of those things, it's down to how well my printer is actually going to print this, whether or not that's going to be an issue, because XT60s don't have anything poking out the bottom, so that won't actually be an issue on that end. It will only be an issue on whether or not my printer prints well. I'm looking at these XT60 connectors actually, and they have a little flange which I did not model up back in the day when I made this model. So let me just check that guy really quick. Alright, so I am getting 12 millimeters flat on the height. And what did we say? I'm going to hit finish sketch really quick. What did we say the height was? 8 millimeters. Yeah, so that means I did not. Let's check this really quick. Yeah, so that is 8 millimeters on the body of it, but again, it has this flange which I'm gonna have to compensate for, so let's go ahead and take care of that really quick. I'm a bit surprised I didn't include that in the original model, but again, just requires a little bit of an adjustment, and then we'll be fine. So this, instead of being wall thickness, I'm just going to make this wall thickness plus, let's see, 2 on each side, right? 8 minus 12 is 4 divided by 2. And I can also add that 0.5 again because I wasn't sure with the printer having extra space. So just bump us up a little bit. So that bumps those guys up. And then I'm also going to want to add some space between for the flanges. So this is going to be 4.5. Actually, that is the wrong direction. Never mind. Cancel. Let's open that up and get the correct direction this time. I want this direction. An extra 4.5. And that is going to make it very hard to get those 12 and 5 volts in there. So that is going to have to also be compensated for. And let's see how 5 looks. 5 looks like it works. And you can see that these are crooked because I didn't bother constraining them. So we'll just go ahead and fix that too while we're at it. So that will be parallel to that, and that will be parallel to that, and we should be good. Now the last thing to do is just to realign these guys. Modify, align. Actually, I will come back here and realign this guy first. That would make sense. And again, I'm just going against the walls because it's easier. Finish position. Darn you. There we go. And then this array just needs to be updated for the flanges as well. And everything is kosher. Easy fix. So we come back in here to this. This is my wall outline, like I said. So we're just going to grab that. And this can be a bit arbitrary. I guess it may or may not be arbitrary. It really comes down to the question of how, because again, this face is going to be in theory laying flat. Let's think about it. So it should be square, I guess. I guess it should be square. It could be a little bit longer. I'm just trying to visualize this in my head. Actually, let's not visualize it on my head. Let's hop back over to the notepad really quick. Just to draw it out on paper. Camera. Put the X260s away really quick. Calipers. Alright. So again, here's this. This is the side view that I have not drawn yet. So there's the desktop. And then when this is popped up, it is going to look like this. These are right angles right here, right? So this length right here needs to be, let's see. It needs to be this width actually, right? So this line from here to here needs to equal that. If I'm thinking about this correctly. So we've got some trigonometry to do, I guess. These are equal, right? So this is an isosceles triangle if I'm getting my trigonometry correct. All right. Well, one of those things I try not to think too hard, and I try to rely on the computer to solve my problems for me. So I'm just going to randomly call this 10 for the moment. And I am going to do this. So let's see. Okay, so this face height is what I'm going to need. So let me just check this really quick. 31. I'm going to actually back up here, I think. And what if I do this? Again, just letting the computer cheat for me. So I don't have to pretend like I... Oh, sorry, Gail. There you go. Now, to be fair, I have tried moving this camera over to the other side since I'm right-handed. so that it's coming from the opposite direction. The problem is that the video quality, for whatever reason, dropped to crap, and I could not explain why, but you could hardly see anything. Now that may have changed now that I put the lights in, but I'm not entirely sure yet. I can retry that again later on. I'll try swapping it back over to the left hand side so that my hand's not in the way when I'm drawing. But this is just what I'm drawing. So this is the front of the panel mount right here. This is the front of the panel mount right here when it pops up. So you can imagine the plugs being the front hand side here, right? So this is going to be the square that I'm drawing right now. And I was just saying, okay, this length right here needs to be the same length as this top right here in order for this top to cover up this hole. So that means that I need to make this triangle, and I need to make this relative to this face the correct size. And that's when I said, well, I'm just going to give up on trying to do math and just let the computer do the math. So this is now the side of the model. I'm going to click that. This is 31, and 31 is, let me see if I have that parameter in here. 31, yeah, so it's going to be face width plus 2x overhang, right? Plus 2x wall thickness. Yeah, so 31 does not actually line up by my math, which is interesting. Let us look at it really quick. 27, oh, not overhang, so it's just 27 plus the 4. Yeah, okay, 27 plus 4 is 31. Okay, cool. That does add up in that case. So I am also going to need this front here, because this front needs to clear the hole. I think I need this front right now. And this distance is the distance I will be going for. So let's turn some stuff off. Turn that body off, and then I'm gonna put all these as a selection group. Selection set, whatever the heck you call it. Select V, there we go. So this is my body right here. I will fix the right angles in just a second. That parallel should not be there. This parallel should not be here. There's that. And then this is collinear and actually centered on that. Alright, cool. This is my face width. Is that right? Yeah, face width. And this is face width plus wall thickness times 2. There we go. And that lines up exactly like I expected to. And then we're going to have a line from here to here. And this is going to have to be equal to this. And computer's saying that is not possible, which makes sense. It absolutely makes sense that that's not possible. Good. Good. I'm glad that makes sense. Because this is a hypotenuse of the triangle, and the hypotenuse of the triangle can't be equal to a leg. So there goes that idea. I was just going to have the computer tell me what this is supposed to be by hitting equals here. But that obviously does not work. Good. So the trick here is that this just basically needs to be larger than this. Yeah, I'm pretty sure that's all that it's going to come down to at this point. So this leg just has to be, let's call it 40. I'm just going to randomly call it 40. Okay. So let's, in that case, I do not need this sketch because it's not actually doing anything useful for me. So I'm just going to back up and get rid of all that, so it's not in my timeline, and we'll hop forward. This now, this should be measured from the front of this guy, and Or actually, I mean, it shouldn't be drawn from the front of that guy, though. Let's see. Alright, never mind. I guess we're just going to do profile. And, again, it is a little bit arbitrary at this point. So, basically, that triangle that I was drawing, the angle that the thing is going to be sitting up is going to be relative to the depth of this, is what it's going to come down to, if I'm thinking about it correctly. So, again, we're going to see what happens with it. Let's see. We want face width plus 2 times wall thickness. So that's equal now. This is now a square. And I want it to be a little bit longer, so plus 10. And we'll call it a day at that. Now, back here. This is going to print like this. So what I want to do is for the hinge. Again, I haven't decided exactly whether the hinge is going to have the torsion spring on it, or whether or not I'm going to put a spring underneath it. I'm still debating that one. But one way or another, we do need a hinge. And the hinge, instead of printing it, I'm going to just run a bolt through, I'm pretty sure. So let's go ahead and get that set up. So I will take this off this side at this point, because I've decided that I do want it. Outside, right side, there we go. This is right, yep, that is right according to cube. So let's project. And then the hinge does want to be in the top left corner, right? If I'm thinking about it correctly, yeah. Yeah, okay, so it may want to be in the bottom right. So if I put it in the top right, so let me just draw this in so that you can see, then this is my pivot radius right here. And you can see as this pivots, it goes forward. If I put this in the bottom, actually I can leave that there. If I move this down here, you can see how this bottom part swings back instead if I have it in the bottom corner, pivoting around that corner. So that's actually what I would prefer. So it will be in the bottom corner. Otherwise, if it was in the top corner, you can see how if the desk ends right here, the hole for the desk ends right here, well, technically right there, then this line goes outside of it, whereas down here in the bottom corner, again, the hole that this is covering up ends right here, and then this pivot circle is outside of that. And technically speaking, this shouldn't be connected here, this should be connected out here, but whichever. Just delete a couple things really quick, get back to here. And for the size of our, I'm gonna just stick for 3mm for the time being. Refreshing chat just to make sure nothing's happening. And we'll just go, I'll go 3mm minus, or plus that divided by 2. I'm just leaving a little bit more thickness on the inside here rather than the 2mm. And this is just going to be a square. That's fine. Okay. And we can go ahead and actually let me draw a how do I want to hook this up? Take a little bit of coffee. So sorry. Normally I bolt everything in right, but obviously this should just be a pin instead, or at least function as a pin. So I don't really need a nut on the other side, is what I was about to draw in, and therefore I don't think I will for the time being. We may draw a nut somewhere because I'm assuming this is going to be a 3mm bolt, therefore it needs to attach to something. but it doesn't have to attach right here. So, and this can go directly to the other side here. That way we got a pivot point on each side. So that is that. And the only thing left to talk about is right now, when you look down, because of these panel mount guys here, I'm going to have a little gap in the desktop where you can see through. I don't really want that. The solution is to extend this out over top, right? The only problem I'm running into at the moment is this 12 meter 5mm thing that obviously if I put a little shelf right here would get in the way. Two solutions. One is just to make this front face a little bit bigger. The other solution is to either move this 12mm. Actually, yeah, I guess I could move this 12mm 5mm down. Yeah, let's do that. All right. Hopefully this will be the last time I have to modify this, and then we can move on to the next part. Come to here. Okay, yeah. I'm going to do this. I'm going to grab the mid plane. I'm going to mirror this guy over the mid plane. Whoops, that is not the mid plane. There we go. So now that is at the top and bottom, and we're going to have this gap in the middle, and I'll put the the text right between that. So this instead, we are going to, let's see, which arm is this? That's this one? Yeah, that's that one. And for features, we'll select both of these guys. And there we go. So now the text, instead of being up here between these 2 points, yeah, okay, it did disconnect there, that's fine. We'll just go all the way down to the bottom. And let's see, how do I want to center it? I guess I will center it like this. And actually, I don't even need these guys at that point. Right? We can just go ahead and grab that guy and hit the center point like that. There we go. Construction line these guys. And they are still parallel. Good. Step forward just to make sure that works. It does. It's a little bit tight. Let's see what my distance is there. Yeah, 0.4mm is a bit tight. I'm trying to avoid making the face any larger, which is why I'm jumping through all these hoops right now. So we will just drop this down by another millimeter. So it's going to be 4mm instead. And then we are going to assume that our printer can actually print that, which might be a little bit of an ask. So there we are. Actually, these guys will have to be readjusted. Control Z. Control Z. Alright, this is a component. I was going to say, I could take, if this was feature, if this one was feature instead of components, I could actually drag this one down to here and do both of them at the same time. So it is probably going, so let's see, Gail. The panel face is going to be all one thing. So this panel face insofar as, let me just, and I lost my selection group. Let me do this really quick, fix this, get that back, select, turn out. So this right here is going to be one piece. I will be, because obviously this needs to, these hinges need to connect somewhere. I will be making a frame basically for it. And that will be another piece, and we'll be designing that next. So it will be two pieces all together, but this panel face itself is one piece printed exactly as you see it right here. Now back to getting these guys lined up correctly. Create mirror, just again doing exactly what we did before. XT60. And then that guy, turn that down to 1 and select that component as an additional component and hit OK. Turn that guy back on and update this. I guess we can't update selection sets. I've never actually tried to before, so wait, update. Oh, okay. I guess that's how that works. So let's go ahead and do that. And update like this then. Alright, cool. Nice. So that's how that works. Again, never tried that one before. And this rigid group also needs to be updated because we changed the nature of these components here. And now we are off to the races. Nice. Okay. So I'm just going to add a little bit of color here. Red, just default red. Plastic, matte red. There we go. And we can come up here and create a new component. And this will be that frame I was talking about. And I'll just call it frame for right now because I don't have a better name. This should be, actually, we're going to hop into power strip because it's a plain relative to power strip. And the question is whether we want it to be flush or whether we want it to be offset. Yeah, I'm not saying anything right now. That's not just your imagination. Making a decision. I guess we probably want it to be flush. In which case, I'm going to want the bottom of this to be the start point for it. So let's get that named. Inside top of power strip. And this was mid plane of power strip, and that is the Z mid plane. And now we come back here and start making that frame. So I'm going to want to take the outside of this guy. Oh, actually, that's one thing I didn't do. The whole entire point of moving these guys down was to put that lip on. I'll come back and... Actually, no, I'm going to need to put that lip on first. I take it back. Alright. I thought I was done with the power strip. Clearly not. So let us go ahead and find this guy right here. Not that guy, evidently. This guy. Selection set, V, bodies, V. And then I'm going to toss just these lines in here. I'm recycling this sketch in order to do the front part right here. So this will be from object, front side. And we're going to object, pound them up, plug, doesn't matter which one I grab, like that. And now that is good. Now we can go back to what we were doing. Come down to frame, hop back into the sketch, and that is now the entirety of what we want to put a frame around. Turn the power strip off. Actually, before I turn the power strip off, turn the sketch off because the sketch is in the way. And one of these things, just thinking for a moment. Yeah, we can probably just offset this. I don't see any reason why we can't offset this. And we'll just do a wall thickness. Like, actually, you know what? I think I do want it a little bit thicker than that. Let's do 4 and see how that looks. So we do this, power strip, distance. This is technically just going to be wall thickness because we did the inside of the wall thickness, but I'm going to use the reference to the object because I can. So that is the frame around the top side. So let us look at that really quick. And I will call this orange, not orange. I want something contrasting a bit more. Green. I want a good contrast. There we go. So you can see this is where that is. Again, this lip right here. Let me do this really quick. That and my axis is going to be this guy right here. Just because it occurs to me that if I'm wrong about something, yeah, okay, I am wrong about something. So you see how we're interfering right here and going through that. So I'm clearing the front side, which is what I was worried about before, but I'm actually interfering with the back side, which is not ideal. So I'm gonna have to reconsider that one, but for the time being we can at least get the rest of this frame set up. And to do that, we'll just drop down an area for this to connect to, and then again I will rework the connection as necessary and figure out what I'm visualizing wrong here. Should not use that one. Come in here, construction. Since I already have this plane, I might as well use it instead of creating more planes. Gonna go ahead and copy that guy, project that guy, whatever you want to call it. And I'm not sure where the pivot point is going to be, so I'm going to go ahead and just do this whole entire area for right now. You can make this a bit smaller. All we really need to do is catch the pivot point and leave a little bit of meat, obviously. But for the time being, this will suffice. To object, there, join, and create mirror feature. And actually, before I do that, again, like we did before, we're gonna make sure we use something based on the power strip itself. So this is going to be an X midplane. That did not select the correct object. Let me turn the frame off really quick. There we go. And now we can go ahead and mirror. One of those things I am building on the, at least I should be building on the origin plane, so I technically don't need this X mid plane, but just to be on the safe side, that's why I'm putting that guy in. So that feature across that mid plane, and we're good. We are not good. All right, that would be the adjust feature. There we go, much better. So adjust basically looked at the fact that I said from this object to that object in the extrude, and therefore it mirrored over this plane, right, to this side, and then extruded back over to this side. So that's why, let's go ahead and put it back just so you can see that. Okay, that's why it filled in this whole entire block. So it mirrored over that sketch from this point right here over the mid plane to this point, which is inside this wall, and then extruded to this object and filled in all this area. So that's why that happened. And actually what I will do is deselect, actually Control Z, Control Y. Lost my history. Identical. But what I meant to do is turn this back into a solid line, and I can move, whoops, darn me and my fingers. There we go. There we go. Now we've got that set up. And we can go ahead, that's the pivot point that we're using. We can go ahead as built that and revolve around that guy right there. And that's our revolve point. And again, I'm going to have to figure out, revisualize this, relook at it, and figure out where that revolve point needs to be and if I need to make other changes. Because I know I've seen these guys on, I think, desks before, and I seem to recall them working correctly, so it should be a matter of where it's pivoting at. The other thing is that the other option is, rather than pivoting, to have it slide. So it could be on a pin that slides up, let's say. I mean, I say a pin, but a slider. It could be on a slider that slides up. That's the other option. Not a bad option. So yeah, one of these things I am just going to have to think about. I'm not going to bother thinking about it on stream because it's such a minor adjustment. Well, a relatively minor adjustment. It's not really so much a design as just a fixing aspect. Otherwise, this frame right here should have enough meat if I'm thinking about it correctly. Yeah. So I will cut out a hole this size, this overall size in my desk, and then plot that down into it, plot the frame down into it, and then once the frame is in place, put this power strip in here into the frame and pin it in place, and that's how that will work. Now again, this right now is based on the idea that this pin that I'm going to have here is going to have a torsion spring on it, which makes it twist, right? So the torsion spring goes through here, connects to this box somehow. It's one of those things, I can glue it in, it's not that big of a deal, and it attaches to the pin, and therefore as it rotates down it charges, and then it releases the energy as it is let up. The only other thing I got to look at, and that's why this is open bottom, is what I'm trying to get at. If I wanted to go with the spring on the bottom, then I would want to actually make this a full enclosure. So I'd want to, actually, yeah, I'll do this just to make the point. I'll just put an extrusion for the frame on the bottom here, and that will give me a floor to put the spring against. So that's a simple change there, but I don't think I don't like that as much as having the torsion spring in there. So that makes us more or less done as far as I can figure, because all the other features I discarded anyway. Yeah, I mean, the only other thing I could do at the moment is just do a little bit of cleanup here, prettifying. Just round these over a little bit. That way it sits on the desk, you know, with a easy transition. But beyond that, yeah, I mean, the rest of it is just fixing this pivot right here so that it actually pivots correctly. And again, that's just going to be a matter of me thinking about it and doing a little bit of research. So that concludes this stream. I'm just refreshing the comments again because they keep on dying out on me. And it doesn't look like we got any more comments. So I'd like to thank everybody who showed up. Thanks for watching. And as always, I hope you have a great, wonderful day, afternoon, or evening, wherever you're in the world. And I will catch you next time.